I and automate driving tasks. I and automating driving tasks. Beginner level. Introduction. I and automating driving tasks refers to using artificial intelligence to assist or control specific driving actions automatically, instead of fully self-driving cars. This focuses on partial automation, where AI helps drivers with tasks like maintaining speed, staying in lanes, parking automatically, avoiding collisions, adjusting headlights, detecting driver fatigue. These systems are commonly found in modern vehicles and are known as driver assistance systems. ADAS. This topic helps beginners understand how AI improves driving step by step. Even before full automation, it teaches concepts such as real-time decision-making, sensor-based automation, control systems, safety systems, pattern recognition. What is AI in automating driving tasks? AI in automating driving tasks means using intelligent systems to handle specific driving actions without full human control. In simple words, AI driving automation equals smart features that help drive the car safely and easily. Examples include cruise control, lane keeping assist, automatic braking, parking assist, collision warning. Why AI driving automation is important. Driving involves continuous attention and quick decisions. AI helps reduce human effort and errors by checkmark assisting drivers, checkmark reducing accidents, checkmark improving comfort, checkmark supporting long-distance driving, checkmark enhancing safety. These systems act as a co-pilot for drivers. Common automated driving features. Feature purpose. Adaptive cruise control maintains safe speed and distance. Lane keeping assist keep vehicle in lane. Automatic emergency braking prevent collisions. Parking assist automate parking. Blind spot detection warn about unseen vehicles. Example driving data. AI systems use sensor data like driving_data equals speed 70, distance_to_car 25, lane_position center, driver_attention low, closing curly bracket. This data helps AI decide what action to take. Simple automation example. Distance equals 10. If distance less than 15. Print. Apply brakes. Else. Print. Maintain speed. This mimics automatic braking systems. How AI automates driving tasks. Step 1. Sense the environment. AI collects data from cameras, radar, ultrasonic sensors, GPS. Example. Lane_position equals left. Vehicle_ahead equals true. Step 2. Analyze conditions. AI checks if action is needed. Example. If lane_position equals center. Print. Adjust steering. Step 3. Make decisions. AI decides the best action. Example. If vehicle_ahead. Print. Reduce speed. Step 4. Execute control. The system controls steering, acceleration, braking. Example. Speed equals 80. If speed greater than 60. Print. Reduce speed. AI and adaptive cruise control maintains speed and safe distance automatically. Example. Distance equals 20. If distance less than 25. Print. Slow down. Else. Print. Maintain speed. AI and lane keeping assist keeps the car centered in the lane. Example. Lane_position equals right. If lane_position equals center. Print. Steer to center. AI and automatic emergency braking stops the car when danger is detected. Example. Obstacle equals true. If obstacle. Print. Brake immediately. AI and parking assist helps park the car automatically. Example. Space_available equals true. If space_available. Print. Start parking maneuver. Eye and driver monitoring. Detects driver fatigue or distraction. Example. Driver underscore attention equals low. If driver underscore attention equals low. Print. Alert driver to stay focused. Full menu-based driving automation system. Python. Def cruise underscore control. Distance equals int. Input. Distance to vehicle ahead. Quote. If distance less than 25. Print. Slowing down. Else. Print. Maintaining speed. Def lane underscore assist. Position equals input. Lane position. Left, center, right. Quote. If position equals center. Print. Adjust steering. Else. Print. Lane stable. Def emergency underscore brake. Obstacle equals input. Obstacle detected? Yes, no. Quote. If obstacle equals yes. Print. Applying emergency brake. Else. Print. No action needed. Def parking underscore assist. Space equals input. Parking space available? Yes, no. Quote. If space equals yes. Print. Parking vehicle. Else. Print. Searching for space. While true. Print. N1. Cruise control. Print. 2. Lane assist. Print. 3. Emergency braking. Print. 4. Parking assist. Print. 5. Exit. Choice equals input. Enter choice. Quote. If choice equals 1. Cruise underscore control. L if choice equals 2. Lane underscore assist. L if choice equals 3. Emergency underscore brake. L if choice equals 4. Parking underscore assist. L if choice equals 5. Brake. Else. Print. Invalid option. This simulates basic automated driving features. Concepts learned from this topic. Learning AI driving automation helps beginners understand. Checkmark sensor-based systems. Checkmark real-time decision-making. Checkmark automation versus manual control. Checkmark safety systems. Checkmark control logic. Real-life analogy. AI driving automation is like a smart assistant sitting next to the driver who watches the road, gives warnings, helps control the car, prevents mistakes. It supports the driver but does not fully replace them. Ways to improve this project. You can enhance this project by adding real sensor data simulation, machine learning for prediction, computer vision for lane detection, voice alerts, mobile app integration, dashboard visualization, integration with real car systems. Common mistakes beginners make. Cross-mark thinking automation equals full self-driving. Cross-mark ignoring sensor limitations. Cross-mark not handling edge cases. Cross-mark oversimplifying safety logic. Cross-mark forgetting real-time constraints. Where AI driving automation is used. These systems are used in modern cars, electric vehicles, luxury vehicles, autonomous driving systems, fleet vehicles, public transportation. Examples of real-world features. Tesla Autopilot, adaptive cruise control, smart parking systems, collision avoidance systems. Simple definition. AI and automating driving tasks. The use of artificial intelligence to assist or perform specific driving actions automatically. Final summary. AI and automating driving tasks helps improve driving safety, comfort, and efficiency. It teaches beginners checkmark automation concepts, checkmark decision-making systems, checkmark sensor integration, checkmark real-world AI applications. It is an important step toward fully autonomous vehicles.